In this example, we want to find the equation of the line that passes through the points 4, -2, -6, 4. Remember, in geometry, for every 2 points, there's a straight line that you can draw that contains those 2 points. And if we have a straight line, there must be a linear equation in 2 variables that's related to it. And so we'll first try to get that equation in the slope-intercept form. Remember, in slope-intercept form, the coefficient of the x is the slope. We represent that with the letter m. And the constant is the y-intercept. That's represented with the letter b. So we want to find the m value and the b value from this information that will then give us the equation of the line that contains those 2 points. Well, if we have 2 points, we can immediately find the slope. Remember, slope, m, is equal to the change of y between the 2 points divided by the change of x between the 2 points. So if we think about these 2 points going from this point to this point, the y value here is down at -2. The y value here is up at +4. So didn't the y go from from -2 up to +4? Wouldn't that be an increase of 6 in the y value? If you go from -2 up to +4, you've gone -2 to 0 would be an increase of 2, and 0 to 4 would be 4 more. That'd be an increase. It'd be a +6 change of y. In the same time, the x went from being 4 over to being -6. It went from 4 to -6. Well, that's a decrease of 10, isn't it? If you go from 4 to -6, you've decreased by 10. So the slope is -3/5. So the m value to put into our equation is -3/5. And now our technique has been to take that slope value along with one of the points that we've been given that the line contains, put them into the equation to find b, because these points have to solve the equation. So whatever b is, it must be a value that would make these points solutions. So if we took one of the points, let's take the point 4, -2. We'll put in -2 for y. We'll put in 4 for x. Put in the slope value of -3/5. And we've created a linear equation in one variable. Now the only variable here is b, so we can solve that equation for b. So multiplying here, I have -2 equals -12/5 plus b. -3/5 times 4, that's 4 over 1, that gives me -12/5. -2, aren't there 5/5 in each whole? So wouldn't -2 be equivalent to -10/5? And so if I want to solve for b, wouldn't I add 12/5 to both sides? And 12/5 added to -10/5 would give me 2/5. So b equals 2/5. So my equation would be that y equals -3/5 x plus 2/5. Now that I found that the b value was 2/5. So here's my equation in slope-intercept form. Make that a little more legible. So this equation has these 2 ordered pairs as solutions, because the line related to this equation would contain those 2 points. And we could plug the values in for x and y to test and make sure that that was really true. Now, this equation is in slope-intercept form. What if we wanted it in standard form? Remember what standard form looks like? Standard form is ax plus by equals c. We we would need to get the x term to be on the same side as the y term, wouldn't we? Which wouldn't be difficult. We could just add 3/5 x to both sides. So now the equation's in standard form, but typically when you see an equation in standard form, don't you see the coefficients as being whole numbers, as being integers? So if we wanted to write this equation in standard form with integer coefficients, we would need to multiply through in order to get rid of those fractions. And the multiplier we would use to get rid of those fractions would be 5. And we would multiply each of the terms here by 5. 5 times 3/5 x would give us 3x. The 5's would cancel. Plus 5 times y is 5y equals 5 times 2/5 is 2. So here's the equation of the line that contains these 2 points in slope-intercept form, and here it is in standard form with integer meaning whole number, coefficients.